Hello sir, so in this video I'll be talking about mini project 2. So we can see that this is the waveform simulation for VHDL design module. So since 4 memory bands is designed in this mini project, therefore I've conducted 4 write and read operation. So based on the setting design, when the signal WR is high, the write operation will be conducted, and when the signal RD is high, the read operation will be conducted. So this one LED green basically is displaying the signal WR and RD. So we can see here when the signal WR is 1 and the signal RD is 0, the result shows 0 1. The 1 0 indicates which indicates WR is 1 and the RD is 0. So same goes to the read operation. When the signal so in the read operation, the signal WR is 0 and the signal RD is 1. The result LED shows 0 1, which means 0 is WR, 1 is RD. And this will be shown on the Altera board. Yeah. So this one LED red is just showing the memory band use. So there are 4 memory bands altogether. And when the LED red is 0 0, it means that the memory band 1 is being used. So if the LED red is 0 1, memory band 2 is being used. 1 0, memory band 3 is being used, and 1 1, memory band 4 is being used. So from this signal ADDRIN here, which is address input, the signal ADDRN here, we can see that it is 0 C4. The 0 here means the first memory bank is being used, and the C4 means the memory address. So like the LED 3 will basically shows the output result for C, and the LED 2 will show the result for 4. So this is my first write operation, and I will be writing data E4, this one E4, into the memory bank of address of C4. So this one LED ones represent the E, and this one LED 0 represent 4. So this process will be repeated until the last of the memory bank, which is here. The first memory bank, second memory bank, third memory bank, and this one is the last memory bank. So moving forward to the read operation. Yeah, this is the read operation. Just like what I said just now. For read operation, the signal for RD will be set to 0, and then the signal WR will be set to the signal RD will be set to 1 to run the operation, and the signal WR will be set to 0. Okay, so this one is the first read operation. So it basically enter the memory bank itself. So first it enter the memory bank of 0, and then it will then read the memory data in the memory address of C4. So we look at the address input here. It shows the value of 0 C4. This one 0 means the first memory bank is being used, and this one C4 is the memory address we used to write on it. And then when you look for the data output here, yeah, so as we can see here, the data obtained is E4. Yeah, so same goes to the rest of the read operation. So this one is the second read operation, this one is the third read operation, and this one is the last read operation. Yeah, so basically we'll be reading what we wrote for that specific memory address of that specific bank. So now I will be performing more detail about the memory address, memory bank, and memory data that I used to implemented on it. So before proceeding to the result shown in Altera board, I would like to talk about the memory bank, memory address, and memory data that I used to present. So I have 4 write operation and 4 read operation. So for each operation, I have 3 steps that control each operation. So there is W1, W1 wait, and W1 rest. So W1 will actually produce the type of the operation to be done in the memory location of the specific memory band, and the memory address and data to be written. For the W1 wait, actually it runs for a few cycles to allow the data to be written on the RAM, and W1 reset actually set the data to high impedance and actually wait for the value to reset. So same goes to the second, third, and fourth write operation with the set memory band address and data. And this will be the read operation, and it's basically will be read what we wrote into the specific memory bank, memory address, and data. So once again, this one is do note that in order to enable the read and write operation, the ALE signal must be equal to 1. So I'll move on to the next part, which is running the program on the Altera board. So before I start my program, I would like to clarify something. So for the first two red LED, it indicates the memory band selected. So if the red LED, both red LED is light off, the memory band 0 is selected. When it is when the LED 9 and LED 9 is 0 and LED 8 is light up, is memory band 1 selected. And when the LED 9 is light up, LED 8 is light off, it is memory band 3 selected. So if both LEDs red is light up, memory band 4 will be selected. Yeah, so this LED indicates a reset button. So when the reset button is being pressed, the system will stop functioning. And these two LED green, for the first LED green, it indicates the write operation, and the second red LED green indicates read operation. And these are the outputs going to present on the Altera board, 77 LEDs. So for the first two 77 LEDs, it will present the band selected, and for the last two red LED, it will present the memory data has been written or read. Yeah, so now I'm going to start my program. Yeah, so for this is the first write operation, and the memory address is C4, memory data is E4. Yeah, this one is high impedance, and it will go to the next step. So this one 0, 1, yeah, for is first memory band selected, and the memory address is 69, and the memory data is ED. Yeah, this one is the third memory band selected, and this one is the fourth memory band selected. This one is memory data, and this one is memory address, and this one is memory data. So now it's going to present a read operation. Yeah, it read the data out, and then it performing the next operation for the memory band 2. Okay, the third read operation. Third read operation, the memory data, the memory band, and this is the memory band. Yeah, going for the last one. Yeah, this is memory data. So that's all for my video. Thank you.